Section A, question 3. In a production process of flour waste, it is known that the probability of the flour waste have defect is 0.145. If five flour wastes are selected at random, find the probability that at most 2 flour waste have defect. Okay, from the story we can conclude that it is binomial distribution with condition 5 flour and defect is 0.145. Okay, you want to find the probability that at most 2 flour waste have defect. At most we can write probability x less than equal to. Okay, to find by statistical table, you cannot find because you have 3 decimal places. That's why you cannot read from the table. That's why you must find by formula. Okay, at less than equal to, you must find probability x equals 0 plus probability x equal 1, and the last one probability x equal 2. Okay, for probability x equal 0, okay, we can substitute inside the formula 5C0 times 0.145 the power of 0 times 1 minus p equal 0.855 the power of 5 minus 0 equal 5 plus 5C1 times 0.145 the power of 1 times 0.855 the power of 6, subtract with 1, you can get 4. 5C2 0.145 the power of 2 times 0.855 the power of 5, subtract with 2, you get 3. Okay, after that from the calculator you can get 0.9685 0.9785 0.9758. Okay, this is a question number 3 for A. For question B, in n selected flour waste at random, the probability that none of flour waste has defect at least 0.1, determine the largest value of integer n. Okay, now with condition you don't know what is the n. X with the binomial distribution with n unknown still have the same probability defect, and situation know that none of the flour waste has defect. None equal x equals 0 because your x about the defect of waste, flour waste. At least with condition at least greater equal 0.1. Okay, you can substitute your x equals 0 inside the formula. NC0 0.145 the power of 0. 1 minus p equal 0.855 the power of n, greater equals 0.1. NC0 equal n, NC0 equal 1 0.145, the power of 0 equal 1, 0.88, 0.855, the power of n greater equal 0.1. To simplify, you multiply log both sides, you get n log 0.855 greater equal log 0.1. Okay, n greater equal log 0.1 over log 0.855. Okay, when you find from the calculator your value for log 0.1 negative, you can get negative value. Log 0.855 also negative value. That's why when you simplify n, you must change the sign of inequalities. You get n less than equal 14 over 7, and your n, the lowest for n equal 14. For question C, using a normal approximation, find the probability that more than 10 flower wreaths have defect in a random sample of size 100. Okay, now your condition X with binomial distribution, your n 100 and your p stays 0.145. Okay, when you want to approximate to normal, you can find the mean n times p equal 14 over 5, and you get variance MPQ 100 times 0.145 times 0.855, you can get 12 over 12.4. Okay, you want to find probability that more than 10 flower wreaths has defect. Okay, when you want to find for x greater than 10. Okay, your question in the discrete spatial distribution. That's why before you get the answer, you must do the correction continuity. Correction continuity. Okay, for x greater than 10, you must make a correction continuity. You can get probability x greater than 10.5. Okay, after get correction continuity, you must standardize, then you can get the answer from the table. Okay, equal probability x greater than 10.5 minus mean 12.4 over the standard deviation square root 12 over 2.4. Okay, you get probability x greater than, after standardize you get z. If I use probability z greater than negative 1.14. Okay, to read this condition, you must change 1 minus probability z less than negative 1.14. Because symmetrical shade, you can read probability z less than negative 1.14 to z greater than 1.14. That's why your answer equal 1 minus 0.1271 equal, your answer equal 0.8729.